Okay, this lesson is on simplifying rational expressions. Simplifying, let's do a quick review on what simplifying is. Take, for example, 2 over 4. What does that simplify to? 1/2. The way we found that out is saying what does 2 and 4 both divide by? 2, and it gave us 1/2. Another way of thinking about it would be if we had written, instead of 2 over 4, if we'd written 2 over 2 times 2. 2 times 2 is 4, so those are equivalent expressions. When you have something that matches on top and bottom of a fraction in the numerator and denominator, you scratch it out. When you eliminate everything in the numerator, it leaves a 1, so that's why it's equal to 1/2. We can do that with variables as well, so go ahead and write this down. X squared over x to the third. What is x squared equivalent to? Well, x squared means x times what? X times itself. What would x to the third power be? X times x times x. Like we did before, we cross out numbers that are the same on top and bottom. We do the same for variables. These cancel, these cancel. When you eliminate everything on top, you're left with a 1 on top over x. So that gave us 1 over x. That's what we're going to be doing, but with more complex fractions like that. All right, let's start with example number 4. So we're going to start down here. We'll come back to example 1 in a moment. So on example 4, we look at the numerator and we look at the denominator. The numerator is already as simple as it can be. It can't be reduced any more than it was, so we leave it as n plus 3. The denominator, however, can be reduced. It's written as a trinomial, 3 terms, and it's got the n squared. So what would it look like when we factor that? What would our answer be here? It would look like 2 binomials being multiplied by each other. Because n squared is the first term, what would be the first term of both binomials? To get n squared, it would be n times n. Remember, in order to find out the next 2 numbers, we think what 2 numbers have to do what to give us 21 and do what to give us 10. It should be multiply to give us 21 and add to give us 10. So we list the factors of 21. What are the factors of 21? 1 and 21. That wouldn't add to 10. 7 times 3. That would add to 10. So it's plus 7 plus 3. Now, the question is, just like we did on the previous problem, we cross out things that are the same on the top in the numerator and in the denominator. I have an n plus 3 on top. Does it match with anything in the denominator? Yes, there's an n plus 3. So I scratch out both the n plus 3 on the top and the bottom. Just like here, when I eliminate all the things on top, we're left with a 1. Same thing here. We just eliminated both things on top, so what's left? A 1. So the final answer is 1 over, what's the only thing left on bottom? N plus 7. 1 over n plus 7. That's the final answer. All right, now we're going to go back up and try number 1. On number 1, we look, the denominator is already as simple as it can be. It doesn't have an x squared like the numerator does, and there's nothing, no coefficient to distribute back out. So it's just as simple as it can be. We're left with x plus 9 in the denominator. So now we have to try and factor the numerator. Well, the numerator has an x squared, just like the one we just did over here. But it doesn't have that middle term where there's supposed to be something x in the middle like we had down here. 2 numbers that multiply to give us 21 but add to give us 10 in the middle. So when we look up here, why in the world are we missing the x term in the middle? Well, when we added it has to have canceled it to make it 0x. That's why it wouldn't be appearing. So what we're looking for is the number that times itself will give us 81, and then one has to be positive and one has to be negative, so that when I add the two numbers in the middle, they cancel out. So for example, if I had 5 and -5, when I add 5 and -5, that would give me 0, so it wouldn't be included in the middle. So what are the numbers that give us 81? What number times itself gives us 81? Well, if you didn't know it, you would try and type it in your calculator till you can find it, but the answer would be 9. And since there's no middle term, you know that one of the 9's must be positive and one of the 9's must be negative. So we're left with x minus 9, x plus 9. We can obviously check it. X times x is x squared, positive 9x, negative 9x, and then negative 81. So now we're looking. That, by the way, is one way you can check to see if we know we're simplifying, then something's going to match what's in our denominator, x plus 9. So you should have known one of these two parentheses has to be x plus 9, and indeed it did match. This is x plus 9, that's x plus 9. So we cross out what's repeated, and we're left with just x minus 9. Now, technically, you don't have to put an over 1, even though we eliminated it and there's only a 1 left. You don't have to write that because if I had an answer of 5 over 1, do you have to include the over 1? No, that's equal to 5. Whereas on our last problem down here, we had to include the 1 because 1 over 5 is very different from 5. They are not equal. So if there's a 1 in the numerator, you must include it. Whereas here, if there's a 1 in the denominator, it doesn't include it because it's the same thing. They're equivalent. So you don't have to have this plus 1, divided by 1 on the bottom. If you did put it, I wouldn't count it wrong, but just x minus 9 is your answer. All right, last example I'm going to work with you. Number 2. As we look at it, we can tell the bottom is a trinomial, so it's going to end up looking like 2 parentheses right there. Since it has a number, a coefficient in the front, you should remember the 3 steps that you do when you have a coefficient on a trinomial. You can do slide, divide, slide, and you could find your answer. However, since it's a small number 2 and this is another small number, I'm going to try and do the guess and check method and get my answer. You do not have to. If you're more comfortable slide, divide, sliding, you could do that method now. But since it's 2x squared, I'm going to go ahead and know that one of them's got to be a 2x and one's got to be an x, because 2x times x gives us 2x squared. Next we think, well, what are the factors of 2? That would be 1 times 2. And the whole point of guess and check method is we're not sure which one's supposed to be a 1 here or a 2 here, or if it's supposed to be the other way. Is that supposed to be a 1 and that's a 2? We don't know, so just guess. Put it down. Now let's try it. 2x times x is 2x squared. 2x times 1 is 2x. And then 2x times 2 times x is 2x. What's 2x plus 2x? 4x. They wanted a negative 5x. So obviously that's not what we're looking for. So we guessed wrong. So I'm going to just erase that 2, erase that 1, and then I try it the other way. Let's make this a 2 and that a 1. 2 times 2 is 4. 1 times x is 1. What's 4 plus 1? 5. We see it's negative. So that means that when I add them, I want them to be negative. Since it's a positive from multiplication, they both have to be negative. Negative 1 times negative 2 gives us positive 2, but when I add negative and negative, it's negative. So there we have the denominator. We look at the top. We're not going to have 2 binomial parentheses like we did on bottom because there's no x squared, but there is a number we can pull out of both of those terms. We can reverse distribute. So what can I pull out of both 7 and 14? You should be thinking that they both divide by 7. We can divide by 7. When I divide 7x by 7 and pull out the 7, I'll only be left with an x. And what about negative 14 when I divide by 7? negative 2. All right, is there anything that we can simplify or cancel from top and bottom? Good, you should be saying the x minus 2. We cross them out, and what's the only thing left? 7 over 2x minus 1. You don't have to include the parentheses because there's nothing else on bottom. All right, at this point, example number 3 is done exactly the same way we just did example 2. You'll reverse factor the top just like we did over here, and then you will binomial the bottom and factor it out to see what you're going to simplify. Go ahead and pause this video, try number 3, push play when you're ready to check your answer. Okay, let's go ahead and check number 3. As we work to our answer, we see the bottom is going to have two binomials. It starts with r squared, so we've got r and r. We want to know what numbers multiply to give us 9 and add to give us 8. At this point, I'm going to pause on this and go ahead and do the top because I want to show you a trick that, if you haven't caught on, might help you if you're having trouble factoring on bottom. Let's factor this top. We've got to see what they both have in common. What can both 2 and 18 be divided by? 2. When you divide 2r by 2, you're only going to be left with the r. And then when you divide 18 by 2, you're going to be left with 9. Now, since we're simplifying, you should know that if this is one of your parentheses, one of these on bottom should match it because we're going to try and simplify them. So as we're looking and saying, well, what number times 9 times itself gives us 9, but added gives us 8? What number, not times itself, but what two numbers multiply to give us 9 and add to give us 8? We take a look and see with one of them is probably going to be a plus 9. Well, what are the factors of 9? 3 times 3 is a factor of 9, but that would only add to give us 6. 1 and 9 would work if we subtract one of them. If it's a positive 8, it would be a positive 9 minus 1 is what would give us an 8 in the middle. So now that we factored it, what can we cross out on top and bottom? R plus 9, they're gone, and we're left with 2 over r minus 1. All right. Your homework, go ahead and flip to the back. Your homework is going to be problem number 1, 2, 3, and 4. And go ahead and change on the bottom here where it says x plus 1, change it to x minus 3. It's x minus 3. All right, get to work on your homework.